Completing the square is one additional mathematical tool you can use to simplify algebraic expressions, solve quadratic equations, convert expressions from one form to another, find the minimum or maximum values of quadratic functions. When completing the square, we can take a quadratic equation like this and turn it into this. The term completing the square comes from the exponent for one of the values, as in this simple binomial expression, x squared plus b times x. In this expression, you have no idea what values x or b have, so how can you proceed? To start, you already know x will be multiplied times itself. Think about a square in geometry. You have 4 congruent length sides, with an enclosed area that comes from multiplying a number times itself. In this expression, x times x is a square with an area of x squared. But wait, we still have unknown variable b times x. What would that look like? That would be a rectangle x units tall and b units wide, attached to our x squared square. To make better sense of that rectangle, divide it equally between the width and length of the x squared square. That would make each rectangle b divided by 2 times x. The new almost square is x plus b divided by 2, but we are missing a tiny corner, which would have a value of b divided by 2 times itself, or b divided by 2 squared. That last step literally completed the square. So now we have this, x squared plus b times x plus b divided by 2 squared. This refines or simplifies to x plus b divided by 2 squared. You need to also subtract b divided by 2 squared if you are, in fact, trying to work an equation, because you cannot add something without balancing it by subtracting it. Let's look at a more complete version of the same thing. X squared plus 2x plus 3. As soon as we see x raised to a power, you know you are dealing with a candidate for completing the square. The role of b from our earlier example is played here by the 2. We added a value plus 3, so now we have a trinomial expression. X squared plus 2x plus 3 is written as x squared plus 2b times x plus b squared. So, divide b by 2 and square it, which you then add and subtract to get x squared plus 2x plus 3 plus 2 divided by 2 squared minus 2 divided by 2 squared. Now you can simplify that as x squared plus 2x plus 3 plus 1 squared minus 1 squared, which is equal to x plus 1 squared plus 3 minus 1 squared. This simplifies to x plus 2 squared plus 2. On a graph, this plots a parabola with a vertex at -1, 2. Now let's see how you can use completing the square to simplify algebraic expressions. Here is a straightforward example with steps. First, divide the middle term, 20x, by 2 and square it. Then both add and subtract it to get x squared plus 20x minus 10 plus 20 divided by 2 squared minus 20 divided by 2 squared. Then simplify the expression. After simplifying the expression, you should end up with x plus 10 squared minus 110. Now, let's discuss the steps to completing the square. 7 steps are all you need to complete the square in any quadratic equation. The general form of a quadratic equation looks like this. And here are the 7 steps. Step 1. Isolate the number or variable c to the right side of the equation. Step 2. Divide all terms by a, the coefficient of x squared, unless x squared has no coefficient. Step 3. Divide coefficient b by 2 and then square it. Step 4. Add this value to both sides of the equation. Step 5. Rewrite the left side of the equation in the form x plus d squared, where d is the value of b divided 2 you found earlier. Step 6. Take the square root of both sides of the equation. On the left side, this leaves you with x plus d. Step 7. Subtract whatever number remains on the left side of the equation to yield x, and complete the square. That's how you complete the square. Take some time and practice using the examples at the bottom of the article below.